Here's solutions to perfect problem 3 for Math 251. We're given this function, this polynomial f of x equals x cubed plus x squared minus 4x minus 2, and told that it's just defined with x values between -2 and +2, and then first asked to sketch this thing. So I said use your calculator. I guess I'm going to let Google be my calculator. I typed it in, this came up. Cool, this is the graph. I only want x to go from -2 up to +2 here. Okay, so I graphed it and I came up with something that looks approximately like this. Pretty bad picture, but whatever, it'll work for our purposes. So use a calculator, sketch the graph, done. Use the sketch that you just did to sketch an approximate graph of f prime. Alright, so this is a little bit tricky. What you want to do is look at this thing in red and draw something else. I'm going to draw it in blue. And the thing that I draw in blue, I want the height of that to be equal to the slope of this thing that I drew. Okay, so I think the easiest way to do that is look for a couple of points, like up here you got one and down here you got one, where the slope of the tangent line to f would be 0. In other words, the tangent line would just be a horizontal line. So if the slope of the tangent line is 0, that means the height of my derivative should be 0, right around there, and then again right around there. So this thing in blue that I'm going to draw has to go through those 2 points. So should it start out above that point or below that point? Well, if you look at the slope right at the start here, this function is increasing. The slope is positive. If I were to draw a tangent line right here, it would be going up. So since it's going up, that means that the height of the derivative should be positive. So it starts out positive and then kind of comes down here and hits this point, and then it drops below the axis because now my function is decreasing. And you'll note that it's decreasing faster and faster and faster until somewhere in here. So it goes further and further down. It starts out going down. It's hard to draw on a computer. And it goes further and further down until somewhere in here, we don't know exactly where it kind of turns around. And now it starts going up. And you're like, whoa, why is it going up? The function's still going down here. Well, yeah, the function's going down, but the speed at which it's going down is decreasing. It's going down slower and slower and slower. So this height, while still negative, should be less and less negative until it gets up to this point here. And then it hits this point, and at this point the function starts going up. It starts out going up slowly at first and then faster and faster. So that same idea will happen over here. This guy is positive, just barely positive at the start, but then it gets more and more positive as you go. Roughly speaking, I'm even going to write very approximate. The derivative in blue would look something like this. Okay, now it actually wants me to find the derivative. So kind of check that answer. Thing that we see won't look like this, but that's okay. It'll be close enough. So what it wants me to do is calculate the derivative of this function using the difference quotient. So the difference quotient tells you that f prime of a is equal to the limit as h approaches 0. Yeah, sure, this is the way we did it in class. I'm going to do it this way. Of f of a plus h minus f of a divided by h. So this is the limit as h approaches 0 of f of a plus h. Well, it's a lot like f of x, except everywhere you see the letter f, you replace it with an a plus h. So I got a plus h cubed plus a plus h squared minus 4a plus h minus 2. That is f of a plus h. And from that I want to subtract f of a. I want to subtract this entire thing. F of a will look just like this, except everywhere I see the letter x, I'm going to instead put in the letter a. So I'm going to subtract a cubed plus a squared minus 4a minus 2. I'm going to divide that whole thing by h. That is a mess, and actually it's going to get worse for this next step. I'd like to evaluate this limit by changing all the h's into zeros, but I can't because of this h right here. I have to cancel out this h before I can evaluate the limit. So the way I'm going to cancel out this h is I'm going to cancel it with an h up in the denominator, but it's hard to see where it is because of all the parentheses and everything going on here. So what I'm going to do is I'm going to expand out all the parentheses and distribute this negative sign. So a plus h to the third power, if you do a plus h times a plus h times a plus h, you will get a cubed plus 3a squared h plus 3 ah squared plus h cubed. That's this thing if you expand it all out. If you do a plus h squared, you'll get a squared plus 2ah plus h squared. Then I got minus 4 times a plus h. If I take that negative 4 and distribute it through, I get negative 4a minus 4h. And then finally I got the minus 2. And then I want to subtract all this stuff, so I want to subtract a cubed minus a squared plus 4a plus 2 and divide that ridiculous mess by h. Looks bad, but it's going to get a lot better. What you'll notice is, maybe I need another color here, I got an a cubed and I got a minus a cubed. Oh cool, those go away. I got a minus a squared and a plus a squared. Those will go away also. I got a plus 4a and a minus 4a. I got a plus 2 and a minus 2. A lot of this stuff is just going to cancel out. So what I'm going to be left with is I got 3a squared h. I have 3ah squared. I have h cubed. I have 2ah. I have h squared. I have minus 4h. Then all of those canceled out with something divided by h. Finally, if you factor out an h from every term in the denominator, or sorry, in the numerator, and cancel it out with this h here, what you'll be left with is the limit as h approaches 0 of 3a squared plus 3ah plus h squared plus 2a plus h minus 4. Kind of took out an h from each of these terms and canceled it with the h on the bottom. And so this right here is a limit I can evaluate now that I've canceled out the h. If I change all the h's into zeros, all the h's that are left, I got 3a squared plus this would be 0, this would be 0, plus 2a. This would be 0 minus 4. This is f prime of a, so f prime of x would just be 3x squared plus 2x minus 4. In the next section, we'll learn how to look at this thing right here and immediately come up with this thing right here. But for now, we don't have that, so we have to go through all this nasty algebra. This is our derivative, f prime of x. This thing in blue that I drew was an approximation of the derivative. What I'm now going to do is I'm going to graph this guy, 3x squared plus 2x minus 4. And take a look at this thing. And what you'll see is this thing right here, very roughly speaking, maybe if I zoom out once, very roughly speaking, resembles this thing right here in blue. And not really. I mean, my picture right here is pretty ugly, and the picture that Google drew is a lot prettier. But it's the same overall shape. It's kind of this parabola shape. The vertex is down here somewhere near 0. We have zeros at about -1.5 and a little bit less than 1. If you go back here, that's approximately what I have here. Not exactly, but approximately. We'll call it good enough. So 1 and 2 we did here. No, that's not true. A and B we did here. C we did here. I just compared my answer. Great. And now I'm going to finally do D. Part D says, now suppose that f is actually the derivative of some other function, which we'll call g. Use your graph of f, so I'm going to use the thing in red here to answer a bunch of questions. So maybe I'll change colors again. This is part D. This was part C. And this was A and B. Part D says, looking at the graph in red, and supposing that this thing in red is the derivative of some other function g, for which x values is g increasing? Well, g is increasing anytime it's, maybe I'll write this. G is increasing when g prime is greater than 0. Right, g prime is the derivative of g, and if the derivative of something is greater than 0, that means the slope of the tangent line is positive. That means that the function is increasing. So this thing that I drew in red here f, I say is actually the derivative of g. Suppose that f is actually the derivative of some other function, which we'll call g. So this thing right here is the derivative. This thing right here is greater than 0 from, should I write this? G prime is greater than 0 from x equals -2, because we're really only supposed to look at this function from -2 up to +2. From -2 all the way to this point to, how about this? From -2 up to, what's this? I don't know, maybe 0.3. And I'll even write that this is very approximate. And then again, let's see, it looks like the derivative is a positive number, has a positive height from, I don't know, 1.7 up to 2. Those two values being very approximate. Part 2 says, where is it decreasing? Well, it's kind of decreasing where it's not increasing, I guess is the easiest way to think about it. So it's increasing from -2 to 0.3, and then again from 1.7 to 2. That would mean it would be decreasing from 0.3 all the way up to 1.7. It's decreasing when the derivative is a negative number. Part 3 says, for which values of x is g concave up? Okay, g is concave up when the second derivative is positive. The second derivative is positive when the first derivative is increasing. So what I got to do is look at the graph of the first derivative, this thing in blue, and figure out where it's increasing, where this thing is going up. Not where it's positive, but where it's increasing. It looks like it's increasing from about 0 up to 2. So I'm going to say 0 to 2. Part 4 says, where is it concave down? It's concave down when it's not concave up. That's from -2 up to 0. And then finally, part 5. Oh, this is going to be tough. Use your answers to the above to sketch an approximate graph of g, assuming g of -2 equals 0. So in another color here, I'm going to try to graph g. I know that g of -2 equals 0. In other words, when the x-coordinate of g is -2, the y-coordinate is 0. So I'll start right here. And then what I have to do is draw something that's increasing from -2 to 0.3, that's concave up from 0 to 2, that's decreasing here, and that's concave down here. So it starts out increasing but concave down. So it starts out going up, but it's concave down, so it looks like this. And then what happens, it hits this point right here, and it starts going down, right? You can see that f prime is a negative number here. And since f prime is the derivative of the thing that I'm trying to draw, when this thing is negative, the thing that I'm going to draw is going down. So it starts to look like this. So it starts going down, and it continues to go down all the way until we get to 1.7. So way over here. It won't be until I get way over here that I start going back up. So it's decreasing all the way from here to here. However, the way it's decreasing is changing. It starts out decreasing, maybe I can draw that a little better. Decreasing concave down, like this. Decreasing and decreasing faster and faster and faster. And then it gets to some point in here around 0 where it's still decreasing, but now it's concave up. So it's decreasing slower and slower and slower until it gets to here, 1.7. And then it hits 1.7. Maybe I can draw that a little bit better. It starts going up, and it goes up a tiny bit, and then my graph ends. That's because from 1.7 to 2, it's increasing again. So I kind of ran out of room there. Maybe I can try this one last time. I'll draw something. Sure, good enough. This right here would be G. These are horrible solutions. Hopefully this is good enough for somebody to follow. But I'm going to end this video here because it's long enough already.